Today we're going to be talking about integration by substitution. Now, integration by substitution happens when we have the integral, basically, of a composition of functions. So let's look at this example we have here. And what we have going on here is let's let u be the inside piece of the function where we're trying to integrate. This is a composition of x squared plus 1, and then the outside function would be something to the 50th power. So if we take the derivative with respect to x, we get part of this 2x that's sitting outside. So du in this case would be 2x dx. So let's look at what we have here. This 2x dx is there. So that's the same thing as u. So now we have the integral of something to the 50th power. But what's that something? That something is our u. And then we have du. Now we can take the integral of that. And then substitute back in whatever your u was. Now, again, remember, if you take the derivative of this, bring down the 51, reduce your exponent by 1, and then don't forget your chain rule, you get back this inside piece. Okay, so let's look at our steps for integration by substitution. Make your choice for u. What I recommend you look at is a lot of times you're going to have the integral of f of g of x. Pick your u to be the inside function. And then somewhere outside, you should see the derivative of whatever you've picked. Okay, and then make your substitution. Hopefully, this is going to be very close to your du. Make sure that the entire integral is in terms of u. No x's should be involved. In that case, if that happens, then you've probably picked the wrong u. Evaluate your integral, then substitute back in your u, and then you get your final answer. Okay, so again, look for the derivative. Look for the derivative of a function when you're picking your u. Our first few examples, they give us the u. So integrate, or take the derivative of this with respect to x. Du equals 8x dx. Now in this case, for this integral here, let's bring the 3 out in front. On the bottom we have our u, so we have the square root of u. We need an 8x dx. I have an x dx, so if I multiply by an 8 on the inside and a 1/8 on the outside, I've really multiplied by 1, I get my du. And I'm going to bring that down here. So now what we have is we have 3/8 the integral of u to the negative 1/2 du. Now I can take the integral of that, add 1 to my exponent, reciprocal of that, don't forget your plus c, simplify, we get 3/4 u to the 1/2 plus c. Now substitute back in what your u was. And again, you can take the derivative of this and hopefully you get back what we started with. Okay, in this case, let's let u equal x over 5, and they give you this u. Now, there's a reason that they give you this u. On the bottom here, we have x squared plus 25. Now, we can actually take the integral of this. Okay, let's get what our du is. It would be 1/5 dx. So I'd need to multiply by a 1/5 there and a 5 outside. I'm also going to bring this 2 outside and multiply it to the 5. So I get 10 integral of something. This is du. Okay, on the bottom, it's not inherently clear to us what I need to do on the bottom. In this case, take and multiply the 5 to both sides. So I have 5u is equal to x. I need to basically get rid of this x. So if I square both sides, we get that. So we have 25u squared plus 25. Now I can factor out a 25 from the denominator. I can bring that 25 out in front. And now we have an integral that we know how to integrate. 1 over x squared plus 1. I don't need my integral symbol because I'm going to integrate. That's inverse tangent of u plus c. Simplifying what's out in front, we get 2/5. Substituting in back for your u, we get that. Okay, so it's a little bit more complicated if you have this x squared plus 25 and you don't have an x on top. If there was an x on top, we wouldn't make the same u substitution. But there isn't. If you just have x squared plus another perfect square, you need to do a similar substitution. Okay, now I don't give you what the u is. You have a composition of functions here. If I know how to take the integral of cosecant of u cotangent of u du. I know what function's derivative is cosecant cotangent. So make your u the inside. So your du has to be 5 dx. So I multiply by a 5 inside, a 1/5 outside, carry down my 1/5, I now have my u substitution. What function's derivative is cosecant cotangent? Well, that is the negative cosecant of u plus c and then our u was 5x plus c. Again, we could take the derivative of that and hopefully we get what our integrand is. Okay, in this one, look at this numerator. The numerator is f of g of x, where f of x is the e to the x function, and g of x is the square root of y. So, what would g prime of x be? Well, that's 1/2 y to the negative 1/2. Well, we have that in our denominator. So if we let our u be what the exponent is, the g of x function, then we know the derivative of that is that. Well, I have part of that. All I'm missing is the 1/2, so I multiply by 1/2 in the inside, 2 on the outside. So I have 2 integral of e to the u du. So in this case now, we integrate. Integral of e to the u is e to the u plus c, and then you need to substitute back in your e to the what your u was. Now take the derivative of that. You should again get back what's inside our integral. Okay, last example, and this one's a challenging one because I don't know what function's derivative is cotangent, but I do know cotangent is cosine over sine. If you make u what's in your denominator, du is 3 cosine 3x. Derivative of sine, then to the derivative of the inside piece with my dx. So I have that there. I just need a 3 and a 1/3. So I have 1/3. The integral, all of this is my du. So I have 1 over u du. What's the integral of 1 over u? Well, that's the ln of u plus c. 1/3 ln of u sine of 3x plus c. That is it for today. Please make sure your lesson summary below this video is submitted on time.